Again, this is Step Talks Education. Let us continue with the calculation in volumetric analysis, and we are looking at a sample theory question, but this time we are looking at what we call percentage purity, or sometimes they can ask for percentage impurity. So let us look at this question here and we see how we can go about with the calculation. You will try to compare this one here with the scope of the calculation that we drew last time on the chalkboard. So we have this question saying 25 cubic centimeters of a solution containing 6 grams of impure sodium hydroxide per liter required 25 cubic centimeters of a 0.1 capital M hydrochloric acid for complete reaction. Calculate the number of moles of hydrochloric acid that reacted, number of moles of sodium hydroxide that reacted. You determine the concentration of sodium hydroxide solution in moles per cubic decimeters. And what could this be? This is the molarity of the sodium hydroxide solution. Concentration in moles per cubic decimeters or moles per liter. Then calculate the mass of pure sodium hydroxide in the impure sodium hydroxide. In other words, they are asking you for the concentration in grams per liter of the sodium hydroxide solution. Concentration of sodium hydroxide in grams per liter. It is the same as the mass of pure sodium hydroxide in the impure sodium hydroxide or in the mixture. And then we determine the percentage purity of the mixture. The percentage purity is like the percentage of sodium hydroxide in the mixture, that is in the impure sodium hydroxide. So that's what we are going to look at. Now the first thing we are going to do is to collect our data for the sake of simplicity of our work. So 25 cubic centimeters of the solution containing 6 grams of impure sodium hydroxide. So we have been told that 25 cubic centimeters, this is the volume of the impure sodium hydroxide solution that reacted, and they told us that the concentration is 6 grams in 1 liter, that is per liter. Then we also have hydrochloric acid. So as for hydrochloric acid, they have told us that the molarity is 0.1 capital M, and the volume of hydrochloric acid that reacted is also 25 cubic centimeters. Now with those we can perform our calculations with a lot of ease. Let us look at A part 1. They want the number of moles of hydrochloric acid that reacted. This one is very simple because we have the molarity of the acid given and the volume that reacted is also there. And what do we say? Since we have the molarity given here, we say 1,000 cubic centimeters of the solution of hydrochloric acid contains 0.1 mole. We have interpreted this molarity here. And then what of the 25 cubic centimeters of the hydrochloric acid? So this one contains 0.1 by 25 over 1,000 mole. So this 2.5 over 1,000 gives us 0.0025 mole. Check from your calculator. And then we can go to part 2. Part 2 now says we have to get the number of moles of sodium hydroxide that reacted. This one is a bit difficult because we don't see the molarity of sodium hydroxide given here, and we have been told that This is impure sodium hydroxide. It is sodium hydroxide mixed with some impurities. That is another substance which is not sodium hydroxide. So the 6 grams per liter is a combined mass. We cannot use this concentration here to get the molarity of sodium hydroxide. So what do we do in this case? We need to write the equation for the reaction between sodium hydroxide and hydrochloric acid. We write the equation and then we look at the mole ratio. So from the mole ratio we can get the number of moles of sodium hydroxide that reacted. So let's write the equation for the reaction. We are having sodium hydroxide solution reacting with hydrochloric acid, which gives us sodium chloride as well as water. Then we can balance the equation. We can see that our equation is already balanced, it's self-balanced, and for that reason we are going to use the mole ratio from the equation for the reaction to get the number of moles of hydrochloric acid. Since we are looking for the number of moles of hydrochloric acid, we shall take hydrochloric acid to the right hand side, and since we know the number of moles of we shall take sodium hydroxide to the right hand side since we are looking for the number of moles of sodium hydroxide that reacted. So sodium hydroxide goes to the right, and we start with hydrochloric acid whose number of moles we already have. So let us try to see this, how to go about with it, but we start with the mole ratio. So since we know the number of moles of hydrochloric acid, we start with it and say 1 mole of hydrochloric acid. Remember, we are using the mole ratio. This is 1 to 1. 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. We are looking for the number of moles of sodium hydroxide. So we take sodium hydroxide to our right hand side. Then what of the 0.0025 mole of hydrochloric acid? It reacts with, we cross multiply, it will be 1 times 0.0025 over 1, and the unit is mole of sodium hydroxide. And what do we get in this case? It will be 0.0025. The unit remains mole. You can see that the number of moles are the same. That's why the mole ratio is 1 to 1. We have used the mole ratio to get the number of moles of sodium hydroxide that reacted from first principles. Now, let's go to the next part. The next part says, that is now part B, we should determine the concentration of sodium hydroxide solution in moles per cubic decimeters. This is the molarity of the sodium hydroxide solution that we are supposed to calculate. And what's the molarity? Molarity is the number of moles in 1,000 cubic centimeters. And remember that 1,000 cubic centimeters is the same as 1 liter, which is the same as 1 cubic decimeter. So we are looking for the molarity, which is the number of moles in 1,000 cubic centimeters of this solution. And now, what do we have here? We have the volume of sodium hydroxide that reacted, and we have the number of moles of sodium hydroxide that reacted. Meaning that this volume contains this number of moles. Then what of 1,000 cubic centimeters? How many moles of sodium hydroxide are there? So we say 25 cubic centimeters of the sodium hydroxide solution contains 0.0025 mole. And then what of 1,000 cubic centimeters? 1,000 cubic centimeters of sodium hydroxide solution. This one contains, we cross multiply, we get 0.0025 times 1,000 over 25. and the unit remains the same, that is mole. So let us calculate this and we get the answer. So in getting the answer, we have 0.0025 times 1000, and we divide by 25, and our answer is 0.1. So this is the number of moles in 1000 cubic centimeters, and that is our molarity, which is our value of concentration of in moles per cubic decimeters as required. So we are done with part B. Let us go to part C, 1 and then 2. Allow me to use this space up here. So let's go for the the mass of pure sodium hydroxide in the impure sodium hydroxide, given the values of relative atomic masses of the elements found in sodium hydroxide. So we are going to get the mass of sodium hydroxide in the impure sodium hydroxide. This one is the same as the concentration in grams per liter, the mass in 1 liter. Now, what do we have? We have the moles in 1 liter. So what we are going to do is just to convert these moles into mass. So it will be the mass, or yes, it will be the mass in 1 liter, which is what is required in this case. So in C, Roman 1, we are going to convert the value of molarity, which is 0.1 moles per cubic decimeter, to mass. And when we are converting moles to mass, what do? We first work out the molar mass of that substance. So the molar mass of sodium hydroxide is equal to 23, 1 atom of sodium, plus 16, that's for oxygen, and then 1 for hydrogen, which gives me 40 grams. So this is the mass of 1 mole. What are we looking for? We are looking for the mass here. We are changing this mole, the value of molarity, to mass. So since we are looking for mass, we take mass to the other side, and we say 1 mole of sodium hydroxide. This time it does not contain, but it weighs 40 grams. And then what of this number of moles? The 0.1 mole of sodium hydroxide. It weighs, and we cross multiply, it will be 40 times 0.1 over 1 gram. And this one gives me 4 grams per liter. So we have changed the value of molarity, which is the concentration moles per liter, to the concentration grams per liter by converting molarity to mass in grams. Then finally, we have to determine the percentage purity. That is the percentage of pure sodium hydroxide in the mixture. It gives us the percentage purity of the mixture. So let's wind it up. In part 2, our percentage purity will be equal to the mass of pure sodium hydroxide, which is here, which is 4, out of the mass, the total mass of the impure sodium hydroxide, which is 6, and we multiply by 100. Let's see what we get. That is 4 over 6 and times 100, and we have 66.66667%. This is the answer, which is approximately 66.67 to 2 decimal places, since we have chosen to do so, and that is our percentage purity. Mark you this: if it was the percentage of impurity, we would firstly subtract the mass of the pure sodium hydroxide from the total mass of the mixture. It would be 6 minus 4 out of 6 times 100, and we would get it. That would be the percentage impurity. That means we first get the mass of the impurity, which we don't know, by subtracting these 4. That's the mass of the pure sodium hydroxide from the total mass of the mixture, which is 6, out of the total mass, which is 6 times 100. That will give us the percentage of impurity. So this is Step Talks Education. Thank you so much for watching.